I hope that you can see my screen and you can hear me loud and well. And welcome again to Choreography, the microservices ballet. Let's go straight into the topic with a couple of funny stories. So once it happened to me that I went to this well-known online website, not the one you're thinking about from the US. It was a European one, and I ended up buying a tablet. And that tablet, the buying process was something like the usual one, right? You select stuff, you put that in the shopping cart, you proceed to checkout, you input your credit card details. Once you submit the order, I got an email saying that my order was on its way and my credit card would have been charged as soon as the order was shipped. And what happened is that a week or so later, it was a sort of pre-order kind of thing. A week or so later, I got an email saying, your order is on its way. Enjoy your tablet. And what happened is that a few minutes later after the email, I started receiving text messages from my credit card company saying transactions denied, transaction denied, transaction denied, and so on for a few hours. So what was clear is that they were trying to charge my credit card, but for some reason, the credit card company denied the transaction. And I was saying to myself, okay, no big deal. They will not ship it. And I'll replace the order and fix the thing, or I'll call support and try to understand what's going on and maybe change the credit card they're using. But surprisingly, 2 days later, I received an email from DHL saying, yep, a package is coming to your house in a couple of days, and I received it. So what happened is that I didn't pay for it, but I received it. And interestingly, I was kind enough to call support saying, hey, folks, I received the thing that I never paid for. And the lady on the line told me, yeah, I can see it. I can see that your order was shipped, but you never paid for it because we failed charging your credit card. But the big deal is that from our perspective, if an order is shipped, the assumption is that it's also paid. So the system doesn't allow me to do anything. So enjoy your tablet. Oh, okay, thank you very much. See ya. And the question then raised in my mind is, how could it be? How can it be that a large e-commerce website fails in such a bad way? And I started brainstorming about possible options. And if you think about the process, was the traditional one, as I said, like order placed, credit card details stored, card authorized probably. So they went immediately to the credit card company and authorized the prepayment. So they were locking the money as they should have done. I have no way to double check if they really did, but I assume they did. And then, as I said, the order was supposed to be charged. The transaction completed shipping time. But at shipping time, what could happen, or could have happened, is that they did an HTTP call to the shipping courier API thing to start the shipping process, and that was kicked off successfully. But then the subsequent HTTP call to the credit card provider to finalize the operation failed, right? My hunch is that it failed for two possible reasons. One thing that happened more or less in that time frame is that my credit card expired. So the card number, the CCV, and all the details except for the expiration date were the same, but the expiration date changed. So for the credit card company, what the card they were trying to use was invalid, right? Or the other thing that could have happened is that the month turned into the next month, and so the authorization they placed at all the time expired again, and so they couldn't complete that specific transaction. But one thing that should catch our attention is that at shipping time, they were making 2 HTTP calls. Now the question we should ask ourselves in such a situation is, what do you do first? Do you first, for example, charge the credit card, which might lead to never shipping? Because if you do the HTTP call to the credit card provider first, you got the money, but then maybe contacting the courier fails, and then you end up with having the money, but never shipping it. And one could say, yeah, we can retry calling the HTTP courier. Fine, right? So the other option is ship first, as they did. And if it fails, shipping first, you're sure you're never charging, right? But then you have the opposite kind of problem. But because if you fail to charge, it's shipped, like in my scenario. And if you think about it, with two steps, like charging and calling the credit card, the shipping courier API, is sort of tricky, but you can sort it out. But with more steps, it starts to become a nightmare. So the more the business process is complex, and if you think about it, the more actors are involved in this business process and it need to be somehow coordinated, the more it's easy, the easier it is that it becomes impossible to manage and all sort of issues will sooner or later happen to the system. Interestingly, when I started talking with people about this thing that happened a few years ago, by the way, they were saying, yeah, those are niche corner cases, Mauro. They will never happen in the real world. And it was just a glitch in the system, and it happened to you, and it never happens to anyone. Sure, I ordered a Millennium Falcon, and I got it twice. And one will say, you're lucky. Yes, I might be lucky, but I paid it twice. So what was happening in this case is that I went to another website, luckily not the same one, another website, I ordered the thing, I received an order number, and all of a sudden I started receiving duplicate emails for all the next steps. So I was receiving, and I wasn't really paying attention to those emails. I was saying, yeah, no problems. The mail server is screwing up things, and I'm receiving 2 emails for the delivery. And then I received 2 emails for the payment. And then I looked up in my credit card and I noticed that there were 2 transactions. So I was charged twice, and a few days later, I received 2 packages. What was interesting is that both packages were labeled with the same order number. So something very bad happened internally to the system, like a duplicate thing happening, that at a certain point started duplicating the entire process and charged me twice, shipped twice, and whatnot, right? In this case, it was super easy to fix the problem. Again, I reached out to support, one was returned, my credit card was refunded, no problems at all, right? But again, it shows that something, when there are so many actors involved into this kind of complex operations, might lead to failure scenarios. And can we summarize and try to understand what's the real problem under the hood, right? And it's probably, we can probably summarize the real problem in 3 main things. The first one is we're coordinating across multiple resources, right? In both samples, I'm using just 2 resources, shipping and finance, just to name them. So we're dealing with credit cards on the one hand, and we're dealing with delivery couriers on the other hand. And both resources, or those multiple resources, have another interesting characteristic. That is, we're using protocols without distributed transaction support. So those resources are not under our control, or even if they were under our control, we're talking to them, in my example, through HTTP, for which we have no distributed or even transaction support. So we cannot really build a sort of a transaction between the caller and the receiver and say, okay, if you fail, I fail. If I succeed, you succeed. There's no way that we are in a sort of an in-doubt situation where I succeeded, but I have no idea what your state is. And if you think about HTTP, HTTP is tricky because we have a sort of a bidirectional communication. So we issue the HTTP request, something happens on the other side, but what could be failing is the HTTP response. So what could be timing out, and we have no idea no way to detect that, is that what failed is the response from the receiver. So the response never came back, but the receiver did what they wanted to do. And so we're now in this situation that is terrible because can we retry? Maybe. is the receiver idempotent? So can we issue the same request multiple times, assuming we have a sort of a stable identifier of the request, so that they can deduplicate the incoming request? Maybe, we don't know, right? And so that becomes extremely difficult to understand what's going on. And the third problem we have here is that remote errors, when using protocols such as HTTP, become a caller problem. So something happens on the other side of the fence. We issue the HTTP request, it goes to the other side, something happens over there, and we got back a 500, an HTTP 500. And now, okay, what happened there? We have zero context about what was happening over the fence, and we are responsible to handle the error. So what's happening is that the receiver is essentially throwing hot potatoes at us without us being able to do anything about those hot potatoes. And the only option for us would be to really keep a sort of a state of all the possible failure permutations of the receiver and all the possible kind of errors that can happen at the receiver, and then try to pinpoint the error that we get to the, oh, it's this situation, so we should be reacting in that way, right? So again, let me recap those three things because they're extremely important. We're coordinating across multiple resources without transaction or distributed transactions problem. We can simply say transactions, right? Without transactions. And the receiver are throwing errors at us without us being able to do anything about those errors. What shall we be doing then? Okay, let's start by one simple thing, okay? No distributed transactions. So let's ignore distributed transaction at all. That's a thing from the past. We cannot really use them anymore, especially nowadays in the cloud, because cloud environments are not really designed to support protocols that rely on extremely reliable network connections, like the Microsoft DTC, or even any kind of distributed transaction thing. Not to mention that distributed transactions are tricky because in a very stable environment, they behave really similarly to local transactions. But in reality, what happens is that they are a collection of local transactions. And so you could be happening in a situation in which you have this in doubt kind of outcome of the distributed transaction where someone committed, someone else is saying nothing. So it's just to give you an example, we recently discovered a bug in the MySQL client for .NET that was exactly showing that behavior. So under heavy load in very specific circumstances, the client was ending up in a sort of an in-doubt situation for distributed transactions, causing the client to not be able to do anything. Because again, a problem in the receiver, in this case the database, was offloaded to the client. And so there was nothing that the client could have done to understand what is going on over there. And so this leads me to the very big deal we're talking about. That is, remote problems must stay remote. How do we get to that? So how do we make it so that whatever happens in the receiver stays in the receiver and the receiver takes care of it by themselves? Okay, it's their problem, they should fix it, right? There should be no chance for them to throw hot potatoes at us. The easiest thing to achieve that is to introduce messages and queues. If you think about it, whenever you have a message in the queue, on a queue, you're decoupling yourself from the receiver. So you're sending a message, but you're not really sending a message to the receiver like an HTTP call. You're sending a message to the queue. The queuing infrastructure will deliver the message to the destination. And so once the message is on the queue, it's not their problem anymore. It's their problem now. And if there are routing issues, the problem is for the messaging infrastructure. If there are receiving issues, the problems should be handled at the receiver, right? So, for example, given that messages are async, as I just described, if the receiver is there or not matters very little. Sooner or later, someone will fix the problem that caused the receiver to not be available. The message will still be in the queue. The receiver will pick it up and do whatever needs to be done. So it's just a delay in time, which might be a few milliseconds, a few seconds, or a couple of hours. But really, from our perspective, asynchronous means that sooner or later it will happen when I don't care that much. Obviously, there are all sorts of consequences by this I don't care that much that requires designing processes in a different way without being able to rely on synchronous communication. But that's matters for a different story. In this case, we're saying if we introduce messages and queues, due to the nature of the asynchronous nature of those two things, receivers problems as in the receiver is not there, are not our problem anymore. Is the receiver busy, so it's taking longer to execute? We should have caused, in the HTTP scenario, a timeout, right? Throwing the problem at us doesn't matter anymore because the message is in the queue. So it's queued up. There might be a backlog of messages in that input queue of thousands of messages because the receiver is super busy. Sooner or later, it will pick it up. Or sooner or later, someone will kick in, scale out horizontally the receiver, and start consuming more messages in parallel. Fine, no problems from our perspective. We sent the message, we're happy. The third thing that allows us to keep remote problems at the receiver side is that messages and messaging infrastructure have this concept of retries. So think about something like a message is picked up from the queue, the processing starts, the business logic kicks in, and there's a bug in the business logic, or the database is not available, or whatever problem, right? Doesn't really matter. An exception is thrown, the message processing fails, but the message is still in the queue. Because given that the receiver wasn't able to complete the message processing, the message has been not acknowledged on the queue, and so it's still sitting there. And so the receiver can process it again. Then we can go into very complex retry patterns, such as, for example, a back-off strategy, where we can say, okay, let's retry this message 5 times, and then back off for 5 seconds, and then try again for 5 times. And then if it fails again, 10 seconds delay, and then try again 15 times, and so on and back, so forth. So what happens is that we can say, is this a transient kind of problem? So we're hitting a database that is busy, so it's rejecting our connection request, but if we try 10 seconds later, the database will be happy because it's not busy anymore, and then we can start processing the message. Fine, good. So we can apply that kind of delay strategy in processing messages to solve those kind of transient problems. The other approach that all messaging infrastructure and messaging frameworks give you is stuff like poison messages or error queues, depending on the type of failures. They might be different things, but it's not really important for today's topic. So if we went through all those retry attempts and all failed, right? Or, for example, if we pick up a message and the exception that we get is deserialization exception, does retrying it make any sense? No, it will always fail. So there's no point in even going through those retries attempt. But what do we do? If we leave the message in the queue, we will be creating a sort of a denial of service to ourselves, right? Because that message will stay at the top of the queue, or even if we move at the back of the queue, sooner or later that message will turn to us again. So we cannot really keep the message in the queue, but we won't want to lose it because now the sender knows nothing about the error, which is the good thing that we're facing. And so we want to say, okay, how do we deal with that? Now we can move the message to an error queue. So it's a sort of a storage where we can get back later and say, okay, why is this constantly failing? Can we fix it somehow? But as you can see, message failures and errors are staying at the receiver end, which is the goal of our process design in this case. But probably one of the things that is in the back of your mind is, okay, but messages are async. That's not fun at all. Because if messages are asynchronous, as soon as senders or publishers, if you will, have sent their messages, they lost control of what's going on. So we need to somehow coordinate across those messages. So let's go through what could be an example of an infrastructure, a process similar to the one I described at the beginning to buy something using messages instead of synchronous requests. Right? So we have available items. Imagine that like being your online web shop where you have pages with stuff, you can pick things and so on. So you can select those items and put those items in the shopping cart. So that's the point. You're happy with your shopping cart, you go to the shopping cart and you click the proceed to checkout link. What happens in the shopping cart internal system, internal design kind of thing? The shopping cart publishes a message on a queue saying shopping cart, check it out. So what's happening is saying there's an action that is sort of irreversible because it's something that happened. It's something that happened in the past. So it's an event that signifies a business transition in the system. So it's an important business change, right? The user wanted to check out the shopping cart. And that's, for example, interesting for finance. What finance does is something, we'll get into that later, and sooner or later we say, okay, payment authorized. So what they did is sending a message, but again, in this case, the message is interesting for shopping cart, but it's still framed as an event. So it's something happened, again, in the system, which is important from the business perspective. A payment was authorized, and in this case, it's interesting for the shopping cart. Which says, okay, I'm fine with the way things are evolving, so the order has been created, which is again interesting for finance, which completes the transaction and then publishes the event payment succeeded. Both those events are interesting for shipping. So what shipping is waiting for both those events in order to say when they will arrive, and I must receive both of them. And that's the only scenario in which I will be able to start the shipping process. Right? We don't want to be in a situation in which those are two HTTP calls, and now we can have all sorts of issues. So if the response to the order created HTTP calls times out, now shopping cart might lead to say that twice, which charges the credit card twice and ships twice for the same order number, for example. So the uniqueness of the message and the fact that those messages are sitting on queues helps in dealing with those kind of problems. Those three are the so-called shopping cart, finance, and shipping policies, or workflows, if you will. We prefer to call them policies because usually they implement business policies. So all those business rules around how do we deal with shopping carts, how do we deal with charging credit cards, how do we deal with shipping and stuff like that. The three policies together are the order saga, right? Think about it. There's nothing coordinating across those three sagas. There isn't an overarching entity like the order manager or the whatever kind of process manager you want that knows exactly in which state the system is at which point in time. But it's a coordination that is more of an orchestration or choreography, I like to call it, like multiple dancers dancing, just following the music, where the beat of the music is keeping the rhythm, but there's no one telling them, do this, do that, do this, do that, do this, do that, now, what, yeah, and so on, right? There isn't really a director that is controlling their movements like if they were puppets. There isn't a master of puppets in this case. Right? So let's dive into the process a little bit more to try to understand what's going on inside, because there are a few things that we want to further investigate to better understand how such a thing could work. Right? So going back, we have our available items. We're selecting items and setting them into the shopping cart. We go to the shopping cart and we proceed to check out. The shopping cart publishes the event shopping cart check it out, which we said is interesting for finance. Finance internally talks to the payment gateway. So talks to the credit card provider saying, hey, again, through a message, saying, again, hey, authorize this card for me. Here is the transaction ID on the message, right? And then what happens is that says payment authorized. Payment authorized, as we said, is interesting for the shopping cart. which says order created, which is interesting again for finance, which now talks again to the payment gateway and charges the credit card using the same transaction ID. So if you think about it, finance is now keeping track of the transaction ID, so it's stateful, because it keeps track of the transaction ID in order to be able to go back in time and say, okay, which was the transaction that I previously authorized that is interesting for this order? This one. And so let me complete that transaction. So shopping cart and finance are talking to each other using as a correlation identifier the order number, but finance itself is interested in keeping track of the correlation identifier, the order number, for example, and the transaction ID that was created when the card was authorized first. Right? And then finance publishes the payment succeeded. And what will finance send into the payment succeeded as correlation identifier? The order number. Because no one cares about the transaction identifier. It's only important for the finance perspective. But the order number that is published on the order created and in payment succeeded is now interesting for shipping. That now it can coordinate again on the order number and say, I received both, right? Because as we said, what might happen is that order created is published, shipping receives it, and then shipping for whatever reason dies, and dies for an hour, right? And then payment succeeded a few seconds later comes in, and it sits in the queue, the shipping queue. And when shipping comes back, it must be able to say, oh, did I receive something about this order? Yes, it's in my stateful storage. And now I can pick up where I left before and continue based on this correlation identifier that is the order number. So again, as we're showing here, all kind of problems you can think about in every one of those boxes stays in that box because of the nature of messaging across, right? At which point, once shipping received both of them, goes to the courier gateway, sends a message to kick off the delivery, and what happens. We don't care at this point because it's not the topic of our talk. There's another important thing that I wanted to highlight here. There is the order in which messages are received from the shipping perspective doesn't really matter at all at this point, right? So in a traditional design, we tend to write code in a sort of a procedural way. We charge first and then we ship, or we ship first and then we charge, whatever, right? It doesn't really matter. We do step A, B, C, D. But what if C happens after D, or A happens last, right? With messaging, that's possible. But the stateful nature of those boxes, of those policies, makes it so that it doesn't really matter if shipping receives a payment succeeded first or order created first, or if there were tens of different events that shipping is waiting for that needs to wait for them all before being able to proceed. It doesn't matter which comes first, right? Shipping will behave like a sort of a buffering logic, collecting all those messages. And whenever it receives a new one, say, how many have I received? 9. I'm still missing one. I'll wait. No problems at all, right? When the last one comes in, shipping can go to the next step. So as we said, the correlation IDs there are the key in order to be able to keep that stateful process alive and be able to go back in time and say, where did I live? Where did I live, right? What was the state when I received this correlation ID the last time? How do I move forward? And so on. But however, failures are still around the corner. So we using messages doesn't protect us from failures. So, for example, how does finance can roll back a card authorization if something goes badly? What something goes badly might mean. Let's go back for a second to this one, right? Let's imagine that finance publishes the payment authorized event, but shopping cart fails in dealing with it. If shopping cart fails in dealing with it, it will never publish the order created event, which will never go to finance, that will never charge the credit card. But if finance never charges the credit card, it never publishes the payment succeeded event. And so now shipping has nothing to do because they will never receive the order created nor the payment succeeded event. And so the shipping will never happen. And now we're left with an authorized credit card because we authorized it, but nothing will come again. So now we have two options if you think about it. And that question should be asked to the business, right? We have two options. Do like hotels do. They don't care. Our credit card authorizations will expire at the end of the month. So when you check in a hotel and they ask for your credit card for any incident that they can charge your credit card for during your stay, what they do is that they pre-authorize the amount on your credit card, and then when you check out, they ignore the thing. By the end of the month, the authorization for which there will never be a transaction will be rolled back to the credit card company, and your card is freed up again. But that's not really a friendly behavior. What if we wanted to be able to roll back card authorization in such a scenario when the shopping cart failed in proceeding after the payment authorized? And you can think about multiple scenarios in which something like that is needed, right? Now let's have a look at what happens inside the reservation checkout during the reservation checkout, and we can ask a question to begin with. That is, do we need a shopping cart failed event? And it's very tempting, right? It's very tempting to say, we want someone else to tell us that they failed, right? But it's violating two things. One, it's violating our original intent. That is, we don't want remote errors to become our problem. But we don't want, and we cannot really have remote errors be our advantage in this case. Because there's no way for shopping cart that might be completely dead, right? The process is dead, to tell anyone, I'm failed, because they're not alive, so they cannot say that they failed. So the other thing that it's violating at a distributed level, it's violating the single responsibility principle. So it's creating coupling between two components. They have no need to be coupled. Whenever you're faced with a scenario in which you are inside finance in this case, and you expect someone else to tell you something to fix one of your problems, it's a smell. You should stop and say, how can we fix this in another way without having them tell us something about their problems, right? And there's a solution using messaging, obviously, otherwise we weren't talking about it. But what finance will do in this situation is the reservation has been checked out, finance receives it, starts the credit card transaction, so authorizes the credit card, and then what it does is sets a timeout for itself, in my example of 38 hours, to release the money. Now, when the timeout expires, the question is it reserved? So is the transaction complete? No, release the money, because it means that no one will ever told us payment succeeded. And we just go back to credit card and say, for that transaction for which we authorized the card 48 hours ago, release the money. So cancel the authorization. Otherwise, if it's the order proceeded successfully, we do nothing. Why we do nothing? Because if the order proceeded successfully, the shopping cart would have published the order created event, finance would have received it, and the payment gateway should have been charged for the transaction. So the payment succeeded. And so we need to do nothing about a known failure scenario, right? So what's a timeout? Now is the important question. Well, it's a message in a bottle for our future self. So what are we doing? We're sending a message to ourselves in the future. And the messaging infrastructure takes care of delaying it. So we're going to the messaging infrastructure, and depending on the messaging infrastructure, there are different ways of doing that. Doesn't really matter the technicalities of that at the moment. And we're saying, hey, can you give us back this specific message in 10 minutes, in 10 hours, in 10 days, at a specific date and time? So we have plenty of options when delaying messages. And that allows us to essentially postpone a decision in the future. if you think about it, it's the buyer's remorse pattern at play. If you ever use Gmail, since a few years, Gmail allows you to send an email and then a little box appears in the left bottom corner saying email sent, undo, right? It's not really undoing anything. It has a timeout that by default, if I recall correctly, is 10 seconds or 15 seconds, something like that, that the email is sitting in the outbox of Gmail on your browser and it's gone nowhere yet. And what happens is that if you click undo, they just undo the send intention. They're not really undoing the send because the email went nowhere so far. So we're applying the same logic here, right? We're saying authorize and then set an alarm for ourselves saying, did we receive a transaction commit for that authorization? No, roll back the authorization. And we're keeping, in my example, a 48 hours delay that business-wise should be enough to say, if within 48 hours we weren't being able to charge the credit card, something is really bad. Something really bad happened. So we want to keep it and release the money and then try to understand what's going on and fix the problem ourselves, right? So we showed in a very short amount of time how we can redesign a process that was meant to be synchronous, introducing messages. And so, if you will, each box that we saw in the diagram were microservices or services. They don't really need to be micro. And how they could orchestrate a business process without having an orchestrator, so a director telling them what to do. So let's go through a couple of takeaways before concluding the talk and opening the floor for questions. So first of all, as we said, is do not rely on distributed transactions, even on-premise, right? Try to avoid distributed transactions as much as we can. They are not safe-proof, so there's a chance you end up with in-doubt situation, which is not fun to deal with. The second one is do not rely on unreliable protocols. And where unreliable protocols, there's plenty. gRPC, HTTP, they are extremely good for certain type of scenarios. They are not so good for other type of scenarios. Backend to backend communication should not be done using HTTP. Client backend communication is HTTP is perfect, right? No problems there. Use messages and queues instead. So instead of using those unreliable protocols, try to use messages and queues. Obviously, they will come with the downside of everything now will become asynchronous. And so you have to deal with the asynchronicity of all those processes. But that allows you to handle errors where they happen and not to offload errors to the senders or to the callers. And finally, use stateful sagas to coordinate in quotes because there is really no coordination. It's just to keep track of your status, like if it was a state machine, and say, okay, my previous state was this one, now I received this trigger, a message, and now my next state will be this other one. And finally, use delayed messaging to model time. So send the message to yourself in the future to model time and to react, especially to react things that you were expecting to happen, but never happened, right? So, and that's exactly why we want to use delayed messaging, because finance is waiting in our example for the order created event to complete the transaction. There's no chance someone will tell them, we failed in creating the order. So finance will want to have a timeout that allows itself to say, I never received it, so I cancel the card authorization. And one last thing is that, as I said a couple of times already, there is no such thing as orchestration. So there isn't really a director or, if you will, a process manager thinking about architectural patterns telling to finance or to shopping cart or to shipping or to whatever component is involved in that long-running business transaction, you should be doing this now, right? It's only the messaging flowing through the systems in a sort of an event-driven kind of architecture that are explaining the new state of the system is this one, and everyone that receives the state of the system reacts and do whatever they want to do based on the new state of the system. And so there isn't, as I said, there's no such a thing as orchestration. Try to not design for orchestration, but more for choreography kind of thing. The business laid out the choreography, and now all the dancers on the stage, they will follow the choreography and react to what's going on the stage, follow the music, react to music changes, and whatnot. My name is Mauro Servienti. As I was introduced at the beginning, I'm a solution architect, particular software, the makers of Service Bus. There are a couple of options to get in touch with me. Slides are already available online. This is the link for all the slides, and thank you very much for having me.
Thank you, Mauro. It was very, very good talk and quite interesting. I mean, it was energetic and interesting. So we have a small amount of time. So the first question, can you recommend some kind of frameworks for the state machines that you kind of mentioned? It's a way to go to solve this problem.
Well, there are a few. One is the one made by the company I work for, obviously, which is in Service Bus. But there are a few, and it's an open source and with a commercial license. So there's a community edition, depending on various things. On the website, you will find all the details. Another one is Mass Transit, which is pretty famous in the .NET space. There are a couple more in the .NET space that allows you to achieve that kind of stateful design. It's important to distinguish between two things: the messaging infrastructure and the stateful design. So we can think about, to some extent, designing the stateful part is not that complex once you solve the messaging infrastructure bits. So there are even now, for example, if you are on SQS, on AWS using SQS and SNS, the AWS folks just released the AWS messaging framework, which only takes care of the messaging bits and not of the stateful part, but that solves, I'd say, 70% of the problems. And so you just have to deal with, how do I deal with statefulness? Right? And that's not that complex. But there are, as I said, if you are in the .NET space, and Service Bus, Mass Transit, Rebus, there's another one called Brighter. They all provide those kind of infrastructure functionalities.
Okay, great. So the next question, it's probably will be final because we have a short time. Is there a difference of implementation of this processing for stateful and stateless services? So it's like, is there any nuances in this area?
Not particularly. It doesn't really matter. I mean, if it's stateful or stateless, the only important difference is that for stateful services, you need a correlation ID. For stateless services, you don't care that much. There is an important bit that is, depending on the queue you're using. So, for example, if you're using RabbitMQ doesn't guarantee exactly once delivery. So there's a chance that you receive the same message multiple times, which will bring you back to, now I'm shipping the same stuff multiple times to Mauro, which is not fun because Mauro will be charged multiple times, right? And so you need to put in place, and those messaging frameworks I talked about, they all implement something about it, a sort of an inbox out-of-box pattern in order to be able to deduplicate incoming messages. Luckily, messages have stable IDs. So that's sort of, it's kind of a solved problem by those messaging frameworks.
Okay, Mauro, thank you. It was very good talk, and it was very good to see you on Fwdays conference. And I hope we all can see you the next year also on other conferences. And it's very good. Thank you very much.
Thank you very much. And thanks.